Last time on Explosive Interviews, we discussed my element, plutonium. Plutonium was discovered in 1940 by me, Glenn T. Seaberg, along with my colleagues J.W. Kennedy, Edwin McMillan, and Arthur Wall. Plutonium was named after the planet Pluto, and its symbol was deemed Pu instead of the more obvious PL because I thought it would be funny. Its chemical properties include a melting point of 640 degrees, a boiling point of 3,228 degrees, a specific gravity of 19.84 at 25 degrees, dissolving in various concentrated acids forming the Pu plus 3 ion, giving off heat energy via alpha decay, and being reactive. The only known method of separation of plutonium is via fission. Common compounds of plutonium include plutonium dioxide, plutonium hydride, and plutonium fluoride. While uses of this element mainly consist of bombs and in nuclear reactors. Most plutonium is man-made, but some plutonium is found in pitchblende ore. The role of plutonium is military-related, being used today in nuclear bombs and weapons. Today, we have a number of scientists, starting with the discoverer of uranium. Please welcome Dr. Klaproth.
Thank you, Glenn. Now, when I discovered this element in 1789, I was working in a laboratory with your pitch blende that you were talking about earlier, and I mixed it in with some nitric acid and neutralized it using a solution of sodium hydroxide. Then I took the element and did what any good pyromaniac would do, and burnt it. I discovered a uranium oxide, but that also helped with the uranium side. So when I discovered that, I decided to name it something a little unique from the sky. So I was like, why not take the Greek god of the skies, Uranus, which is also a planet. So a couple more properties of this element is a slightly radioactivity, not too bad. And it dissolves readily into nitric and hydrochloric acids, tarnishes in air quite quickly. And when divided very small, it can readily combust. And when it burns, it releases a very poisonous gas. But more current research that we're doing that I've, indulged myself into is we're trying to figure out ways to obtain uranium from the sea water. So we're taking that because it's inside the water, not in minerals in the ground. So we decided, let's see if we can't get uranium there. It's a little more environmentally friendly. And then some more history about it was back in 1944, the U.S. was in the World War II. And they needed a solution for it very quickly. So they took my uranium and they built a bomb out of it called Little Boy.
Ah, yes.
And they dropped it on a city in Japan called Hiroshima. And that was just the first of two to end the war. And the second one was a different bomb of a different nuclear source. And that ended the Second World War. But now it's turned to other nuclear weapons. And it's a very big topic on the nuclear side. But now it is used in a medical field for cancer treatment, and that's just mainly the uses it has outside of military.
Well, fantastic. Thanks for coming, Martin.
All right, well, thank you, Glenn.
Stay tuned for our next guest, the discoverer of radium. And we're back on Explosive Interviews. Here with me now, the discoverer of radium, Dr. Curie. Dr. Curie. Oh, jeez! Dr. Curie! Goodness.
Hello.
Welcome.
So glad to be here. Radium was discovered by myself and Madame Curie in pitchblende. We use literally a ton of pitchblende to get a very tiny amount of radium. It was very painful work and hard and overall just terrible. And the word radium comes from the Latin word for ray. Also, another reason is because I like Space Invaders. So that's a big reason. Some properties are that it is naturally radioactive, it glows, and its most common isotope is radium-226. It is used for glowing paint, watches, aircraft instruments, and other instruments until people realized how dangerous radium was and they just got away with it and replaced it with other, like, less fashionable people. It is also used as a neutron source. It does naturally occur in the environment, but you'd have a hard time finding it. Let's just say that. Do you like brilliant white, by the way?
It's brilliant.
Yeah. Okay, so radium in its pure form, it's brilliant white. But do you also like black? The color black?
Indeed, I do.
Yeah, because once it's exposed to the air, it becomes black. It also emits alpha, gamma, and beta rays. It is used for treatment in some diseases, but can cause cancer if you're exposed too much. That is what happened with me and Madame Curie. I'm dying at the current moment.
Well, I'm glad you chose to come on this show for your last final dying days.
Me too.
After this quick commercial break, I'll be discussing radon with Dr. Dorn. And we're back on explosive interviews with Dr. Friedrich Ernst Dorn. Friedrich?
Guten Tag. I'm glad to be here, Dr. Seberg. Folks, I'd like to talk to you all tonight about the element radon. Now, I discovered radon back in the year 1900 while studying radium's nuclear decay chain. That's actually where the name radon comes from. It's derived from radium. Now, there are a few important facts about radon that's important to help you distinguish it from other elements. Radon is a colorless gas, and it's in fact the densest gas known to man. When radon freezes, it produces a brilliant yellow phosphorescence.
Ooh.
Yes, it's very shiny. It is chemically unreactive, but it is highly radioactive, and it has a half-life of about 3.8 days. Radon is used in a lot of scientific procedures. It can in small doses treat cancer, and it's also used in earthquake prediction.
Ooh.
But it also has downsides. Radon can be found in the granite foundations of homes, and it can be harmful if ventilation is not used to mitigate the harmful effects of radon. And these harmful effects would be that radon harms lungs and can lead to lung cancer. And current research is being conducted to study the extent to which radon harms lungs. So it's just a good idea to make sure your ventilation is working to be safe.
Glad to know that. That's all the time we have today, but tune in next time for our Thanksgiving special where we discuss why tryptophan makes you sleepy. It doesn't.